Okay.
And Karthik, I see that you are recording this meeting.
Okay.
Okay, Ashish, let's go ahead with wherever we left off. So the other day we were saying about what's a graph, what are the individual items or the components that will be used in a graph, and then we were saying about the DML.
Right.
That's how Initio interprets the incoming source or target data. So let me just briefly sum up what we see about the DML that day. So here I have the sample DML that we have seen. Record and end will be the keywords used to start and end a record format definition. And inside record and end keywords, we will be having the individual field definitions with their own data types and delimiters. So after we define the delimiters and the data types, the field names will follow. So every component in Ab Initio should be having its own record format so that it can recognize what type of data it is dealing with. Okay, so be it any component, whether it's input file, an input table, a reformat component, any component, it needs to have a record format definition associated with it. Okay. So here in this screen, you can see that I have used an input table component in the working area. So when I double click the component, it will open up properties. So are you able to see the properties dialog box?
Yes.
And we have multiple tabs associated with it. And the last one is ports tab. So that's where we have to define our record formats for this particular component. And there are multiple ways to define the record formats. As you can see, there are 4 options here: propagate from neighbors, same as, path, and then embedded. We'll go one by one. So if it is embedded, we are going to manually type the record format definition in the space provided here. So as you can see, there is some information that is typed here. So if it is a path, you have already record format defined somewhere else in a file, and you are going to use that file. So and that record format definition should end with an extension of .dml.
Right.
Okay, and there is one more option called same as, which we will be using to use the record for other components.
Okay.
In the same graph.
Okay.
So as soon as you click on same as, in this combo box, it will list all the labels of the other components that are present in this graph.
Right.
So you can click on them and choose from which port you are going to use the record format. And the last one is propagate from neighbors. So it is just a miniature version of same as, where you can use the record format of the neighboring components on the left and right hand side.
Right.
So by default, every component you get into the working canvas for the graph will have the propagate from neighbors option enabled. So by default, it will automatically take from the left or right side components.
Okay.
And then you have to change it as per your requirement.
Okay.
So basically, you will be giving the record formats when you are using a source component, and then you will be propagating it throughout the graph till the endpoint,
Right.
unless there is any change. Okay?
Yep.
Pretty much fine, right? For the 4 options here.
Yes.
And we have an advantage with the database components when specifying DML. You see there are 3 options here on the right side. Edit, generate and validate. This generate button will be enabled only for database components.
Okay.
So what Initio can do is it can generate DML from the table specification of that database. Suppose if you are trying to read an employee table into a graph, so it can read the employee table specification from that database and it will automatically create a DML for you.
Okay.
So this option is available only for database components. Of all the other components, the generate button will be disabled.
Okay.
Let me see if I have that screen here. See here, this is one more component in the same port stack. The generate button is disabled.
Right.
And below that we have the validate button, which will be used to check the validate the syntax of the entered record format definition.
Okay.
So let us go back to that slide. Okay. I have listed out the various methods to create the DML. For database components, we can generate using the generate button, or we have to manually type and create the DML. Either it can be embedded in the component, or we can reuse an existing DML file.
Right.
So the command prompt version of the generate button. So that's what it is shown as an Unix command here.
Okay.
We have a backend command from the Unix prompt that we can use to generate the DML. So it is called m_db gen DML mydb.dbc, and then we have to give the table name. So it is one of a component, it is one of a command that is used to generate the DML. It uses the parameters dbc file and the table name. dbc file, let's think of it as a configuration file which will have the parameters to connect to a database.
Okay.
So for this particular command to work, we need a database configuration file and then the table which we are trying to create a DML. Okay.
Okay. Karthik, I have a question.
Yeah.
If the DML is to be used in the graph and we have the generate option there, why do we need the Unix command?
It is an extra advantage that is provided as a backend version. Actually, what the generate button does is it will invoke this command in the backend.
Okay.
So when we don't have the GDE with you,
Okay.
at that time we can generate the DML using this command and we can store it in the form of a file. We can route this output into a file and we can store it later for use in the GDE.
Okay.
When you don't have the GDE license, you can work from the backend.
Everything that is done in GDE can also be done from backend?
Not entirely. Your graph development cannot be done.
Okay.
But you can go through the directories created, you can see all the files, you can execute the graphs, you can see the log files, everything. But you cannot develop a graph without a GDE.
Okay.
You can create the DML files, you can edit it, so those kind of things can be done. Let's see about this backend commands in the future sessions later. So as of now, we will be using the GDE to generate DMLs.
Right.
And the next concept is XFR. So as I have already told you that whatever the data that is read from a database or a file will be transformed and then it will get loaded into the data warehouse, whether it may be a file or a database. So that transformation can be performed with the help of the transformation functions or the built-in functions which is available in Initio. Similar to DML, your transform functions can be embedded within your component or it can be externally stored so that it can be reused in some other graphs.
Okay.
So those functions comes with an extension called .xfr. Okay, is it clear?
Kind of, but I'm not very clear on what, like, how a function works within a component.
Okay, think of the filter by expression component that we have earlier seen, right?
Right.
So that particular filter by expression component had a condition to filter the records.
Right.
So that condition can be embedded within a component or it can be stored outside in a file, similar to how DML is used.
Okay.
So those kind of things are called transform functions.
Okay.
Which are used to manipulate the data.
Okay.
Right? So see a sample transformation. We have an input data with this particular record format and I want the data to be transformed into this type using this data type. You can see a simple transformation logic applied in the data. We have an ID column with 4 digits and then we have a date column specifying the date format and then we have first name and last name column, right?
Right.
But in the output I want the data to be like this. I want the first name and last name column to be concatenated and brought next to the ID column and the joining date column is sent to the last.
Right.
So this is a simple kind of transformation. So to do this, what you will be writing in this inside a transform that will look like this. So you have to use a reformat component to manipulate the data, to reformat the data, right? So a sample reformat function looks like this. First I will write it down and then I will explain it to you. That's it. So this is a sample transform function for this particular transformation. So as you can see, the syntax for the transform function starts like this: out, two colons, and then the function or the component which you are trying to apply. So if it is a reformat component, it will be written as reformat here. If it is any other component like a join, a rollup, or a scan component, so that type of function will be listed here. If you open up a joins transform function, you will have the keyword join here, and then the number of inputs it is processing. For reformat, it will be having a single input port, so it will be having in. For join, in this case, it will have in 0, in 1.
Okay.
And then the begin and end keywords. So this is how a reformat transform looks like. And your transformation mapping rules should be inside this particular block. And for every output field that you have defined in your output port DML, there should be a transform mapping available.
Okay.
And I have explicitly specified individual mapping rules.
Okay.
You can see that I am directing the ID column from the input straight forward to the output column, right?
Right.
So the syntax should be out dot field name and then two colons in dot field name,
And
whatever I want to use from the input. And in the name column alone, I am using a simple built-in function for the concat to concatenate the two columns in the input, first name and last name.
And
for ID, yeah, tell me.
Two questions. One is like, are the spaces mandatory, or how does it work? Or can I give more than one spaces as well?
Or spaces here?
Yeah.
Spaces is not mandatory. I have just given it for readability.
Yeah. Okay. And can the concat function have more than two inputs? Two parameters, like herein we are joining first name and last name. Can I have more than two?
Yes, it can. Yes, it accepts more than two inputs. And so everything will be concatenated at the end.
Okay. For an example, I want to trim, I don't know if this one trims the names or not, but let's say I want to trim the two names and then add a space between them and concat. So can I have nested functions or something?
Yes, you can do that. For trimming, we have another function, so we have to use on top of this.
Okay.
And if you want to include a particular space or something between, so you can just simply type in here,
comma this.
Yeah. So it should be an argument, right? So
Right.
ideally you are trying to put a value here, and we don't have a defined variable that is having a default space value.
Mm-hmm.
So I am hard coding it directly. So instead of this, what you can do is you can define a variable and then you can use that variable here.
And let's say if we have to define the variable, so how do we do that in this function?
So either outside your transformation function, that will be regarded as a global variable, and if you are defining it inside your function, that will be regarded as a local variable. So for every variable, similar to fields, they should have a data type, they should have a return value.
Okay.
So similar to all the other programming languages, so let's string of, let's say, a default delimiter blank var. This is how to define a variable.
Okay.
And then you want to assign a value to this variable so that we can use it in the function, right?
So let is the variable, like how you define it.
Right.
Okay.
And if you want to use a default value for this variable anywhere, you can just type equal to here, and then you can use the assignment operator, sorry, the double quotes, since it is a string, and then you can assign it here.
Okay.
So later you can use that blank variable in the middle. So anything which is not used in conjunction with in or out will be treated as a variable.
Okay.
So ab initio, by default it will consider it as a variable and it will look for a variable definition before the starting of the rule.
Okay. And what is this \n?
So for every data type we have to define the delimiter, right? Even
Right.
though for a field definition.
Right.
So that delimiter or the length of that particular variable should be defined. So in this case we don't want a particular length for this variable, so I have just given a default delimiter.
Okay. And like since it is one character, I could have also chosen to use a string one character, right?
Absolutely. You can use it here. So let's string of 1.
Okay.
And don't consider these two quotes because we are just using it to interpret it as a string.
Yeah, that I understand. And
Yeah.
the other day we had also talked about that we could use single quotes or double quotes, whatever we want, right?
Yes.
Okay.
And the real difference occurs when you're trying to reference other variables inside your transformation functions. Single quote does not extend your references and it will literally reference those values. So it means like if I'm trying to reference other variables inside your quotes, your single quotes does not extend that capability and it will literally put whatever we have written. On the other hand, double quotes extends the references.
Okay. And
So it is just an advanced topic. Yeah, I will tell you. This is an advanced topic where we work on the parameter references.
Okay.
So parameter references, either we can reference an already defined parameter or an already defined variable.
Okay.
Suppose you have another variable here that has been defined, $myware. Okay, so in that case you have to use that dollar and then the variable name, to reference that variable's value for blank var here.
Okay.
Okay, and suppose if you are using it in a function, or if you are using it in a transform definition, now we are assigning the value to it, so we are directly using equal to that one. Suppose you want to use this particular dollar sign and then that variable. So in that case, I'll be using this. So it doesn't interpret the dollar references. It will give the value dollar $myvar.
Okay.
On the other hand, if you omit your quotes, it will take the reference from the $myvar variable.
And if I put double quotes, it will force the value of $MyVAR in blank underscore var.
Absolutely. But we don't need that value here because it is already a string.
Okay.
Right? Suppose consider the my variable is defined as a decimal. So in that case, we cannot assign a decimal value to a string value.
Okay.
By default, it will automatically typecast it, but to be on the safer side, we can just enclose it within double quotes. So it will treat it as a string value and still it will reference the parameters here. Okay.
Okay.
And the main thing whenever we start our transform definition is this two lines will get automatically populated whenever we start to type our transform functions. We just need to type these lines, and this particular view is called as text view in your transform definition. There is one more view called grid view where you can see the input and output variables listed in left hand side and right hand side, and you have to write your transform mappings in the center by dragging and dropping the field names. You can choose to toggle between grid view and text view. So if it is text view, you just have to type it yourselves, everything, like whatever we type in the embedded DMLs. If it is grid view, we can just map it from the input column to the output column. Ab initio will automatically write the mapping rules for you. So once you finish dragging and dropping, that is mapping input fields to output fields, if you choose to switch to the text view mode, you can see all the mapping rules written.
Okay. So basically, majority functions you can do through the grid view, and then if you want to make a little tweak, you can go to text view and make changes.
Exactly.
Okay.
Yes. And since there are three fields here, we just have written it like for every transform definitions. We have also wildcard functions that can be used like this. So instead of all these things, if there is no transformation that I have to do, I can do like this. Simple. Out dot star, in dot star.
Okay.
So every field will get mapped automatically.
Okay.
Other than those, if I want to do a particular transformation on a particular field, I will be writing like this. So
Okay.
in our case, both these will work. You understood, right? We have minimized two lines into the usage of wildcards. The other particular transformation what we had,
Okay.
it is there. For the other two rules, ID and the joining date column, we have just replaced it with the usage of wildcard rule.
Okay. And by mistake, if I do in the opposite order, that out dot name is first, this the row is replaced by toggled if I switch the two rows, then what happens? Like
Okay, excellent question. There is no priority for the roles here, so you can just mention it either ways. You just have to have a explicit mapping rule or a wildcard rule specified. But you cannot have both, right?
but herein we are having that, right? That we have both wildcard and explicit rule, wherein like all the fields are mapped, and
Yes.
okay, the other two fields are F name and L name. That is why it's not there.
So how the wildcard works is, whenever we have an explicit definition, it will not be used. So the wildcard will be applicable only for the other fields. Whenever we have an explicit rule definition, ab initio will not use the wildcard for that particular field.
Okay. So it
And
matches, right?
And you cannot have more than one rule for a particular field. Suppose like this. So if you write like this, ab initio will throw an error like more than one assignment for output.name field.
Okay.
Okay, and to mitigate this, what we can do is we can assign priorities for the rules. And to answer your question, the usage of rules, like whether it is first, whether it comes first or second, doesn't matter. We just have to use the correct field names and the correct output field names, and the order is really dependent upon the DML definition. Okay. However, you can write your rules. You can just write your mapping rule for name in the first or last. It doesn't affect the output column or the output data. So how the output data will be assigned is according to your DML.
Karthik, I have a question.
Yeah.
Herein, the output and input had record format differences. Like the DML was different for both input and output. Like
Yes.
in input it was first name and last name, whereas in out we have only one name, that is name.
Yes.
Right? So, like if we had same names, let's say F name and L name in the output as well.
Okay.
Right? And let's say my intent was only to do a substring on first name and last name, that I trim it to like for 25 characters or something.
Okay.
Right? So will this still work, that out dot star colon colon in dot star and then out dot F name colon colon substring of this and out dot L name is this. So will that work? Or
Yes, yes, absolutely. That's how we need to write. So you just basically have to define your DML beforehand, and then you have to write your transformation. If there is a change, and if there is a change in the number of fields and in the form of the fields.
okay.
Or what you can do is you can write down the mapping definition, and if you drag it to the right side editor in the grid view, it will automatically create the DML for you.
Okay.
But the name will not be correct. The name what ab initio uses is just an expression 1 or expression 2 something according to the data type. You just have to later edit the data type field name alone. But the data type field, everything will be similar. You just have to edit the name according to your preference. I will show all this when we get the software. So as of now, you can just keep in mind that so as I'm telling, we need to have the record format beforehand before writing the transformation. It is not really needed to have all the record format definitions beforehand without writing it down, because we don't know what will be the output data type when we write a transformation for all the functions, right?
Yeah.
So what we can do is we can just go to the grid view, tap in the center of the transform rule, edit the transform rule, finish up the function, and from there we can drag it to the right side output fields. It will create the output field and data type for us.
Okay. Probably I'll be able to more understand when we do the software and we do it, right?
Yes, that's right. And right back to where we are discussing the priorities. So we cannot have more than one assignments for an output fail. So in that case, we just have to rely on the usage of priorities for the transform rules. So using priorities for the transform mappings is very simple. You just have to type in the number for the priority which you want to use. So how priority works? You just have to type in the number between the colons. So the priority starts like this from the number 1, number 2, number 3, and the default will be without any colon. So first
This is the highest one. Default
yeah,
is the highest.
yeah, yes.
But how does it differ? Like, what difference does it make?
If the first name column is having a valid string value, those logical things, everything can be done. We have if statements, we have loops.
Okay.
Everything here.
Okay. And we'll talk about them later, right?
Yes, yes, of course. Do you have any doubt in this
No.
sample reformer function?
No.
So let's move on to the file formats or the file types that we use in Initio. So basically it is divided into two types, serial files and multi-files. So serial files and multi-files have a different notation in your GD. So it is a single cylindrical shape, and then we have lines inside it, multi-files. And your serial files will have the layout as 1, and multi-files will be having the layout according to their parallel behavior. If that multi-file is created from a two-way multi-file system, it will be having 2. If it is four-way multi-file system, it will be having 4. And you're fine with that two-way, four-way specification, right?
Yes.
If it is two-way multi-way system, then it will be having 2 data partitions. If it is four-way system, it will be having 4 data partitions.
Yes.
We just have words describing serial files and multi-files. I'll just read it out for you. The term serial file in Initio refers to flat non-parallel files. So it's a flat file without having any particular data partitions, only single data partition. And a multi-file is a parallel file that is composed of individual files. The individual files are called partitions. Every multi-file will have a control partition and one or more data partitions. And the data in a multi-file is usually divided across number of partitions which can reside on separate disk or systems. So when we have our multi-file system spawned across multiple devices, then we will have huge performance difference.
Apart from performance or like resource utilization, there is no other difference like between a serial file or multiple, right?
Right. And the data partitions if they are lying in the same computer, that is different than when the data partitions are in different computers. We will be using the resources of that particular machines.
Right.
So your parallel performance will be increased tremendously.
Okay.
And regarding your serial files, they will be having only single partition, and it will use that particular system's resource.
Okay. And it's kind of similar to like you have two hard disks in your let's say laptop or desktop, and you create two partitions on both of them. So that's basically the concept behind multi-files, right? That
Yeah, yes.
okay, got it.
Yes, but in our desktop partitions and all, we will not be storing the file. If you're storing the file, it will not be stored in those two data partitions at all. It will be stored in single partitions, but the term partitions can be related to these things.
Right.
Okay. The next concept is parallelism. So Initio can process data in parallel runtime environment. So it supports three forms of parallelism: component parallelism, pipeline parallelism, and data parallelism. So let's see how Initio supports these three types of parallelism. So component parallelism occurs when program components execute simultaneously on different branches of a graph. And let me tell you one thing, these three parallelism concepts which Initio exhibits will be decided by it through the usage of components by us. So when we have a certain types of components and we have a certain programming language that we use to connect those components, based on how we have connected the components, it will try to use one of the parallelism methods and try to maximize the performance.
And we don't have any control over it, right?
The parallelism concept which it uses largely depends upon the usage of components. So we can actually switch from one type of parallelism to other type of parallelism, but we cannot choose it. Like if I want to use this one, use it. If I want to use this one, use it. That we cannot do.
Okay.
But our action determines the type of parallelism which we get. Okay.
Okay.
And there are certain points so that the Initio can decide which type of parallelism can use. So if you are trying to override that particular behavior, then that particular parallelism cannot happen. So in that case it would default.
Okay. And like whenever we are executing something, do we come to know that what is Initio actually using to do that?
We can see from how the components executing, whether all the components are running at the same time or whether one particular component is waiting for the input from the another component. So in that case we can decide. So parallelism is nothing but when we are doing multiple things at the same time. So if all of the components are running at the same time, then you can say that it is executing some kind of parallelism.
Okay. Like there are, I mean, meant to ask was that there are some kind of monitors wherein we can see that, right?
Yeah, yes.
Okay.
So let's see about the component parallelism with this example. Here we have two branches. This is sample graph. We have a customers file. We have transactions file. We are sorting the data. We are joining the data, and the output is stored in an output file. So in this particular graph, we have two input files, two sort components, and a join component and an output file component. So if you run this graph, since we are having two source branches and we are applying sort on both of the branches, these two sort components can run at the same time. So when different instances of the same component run on separate data sets, component parallelism will occur. We cannot really say that the sort and join component will run at the same time, but these two sort components will run at the same time. So this particular graph exhibits component parallelism. Okay, so the more number of branches you have, the component parallelism will be higher. Because the particular first branch is not dependent upon the second branch to execute, right? And of course we have something called phases, wherein you can decide which particular components execute at a particular time. So in that case you will be modifying the default component parallelism behavior. So I can specify like I can show that to you in the example graph. Okay, here phases are not mentioned. See this example here, the blue color boxes with numbers in them. This is called phases. It shows at what phase the particular component executes. You can just change the phase of every component so that it will execute at a later time. Thereby we can utilize the resources effectively. So by default every component will have 0th phase.
Okay.
Such that every component will start at the same time. Suppose if you want to start a particular component after some components have executed, then you will be increasing the phase of that particular component. So in that case, if you are increasing the phase of transactions on this sort component, then these two sort components will not execute at the same time, correct?
Right.
So you will be modifying the default behavior of component parallelism. So in that case, component parallelism cannot happen.
Right.
So like this, the types of parallelism which the graph exhibits will be largely dependent upon our actions.
Okay. And in fact, by doing so, we can also pick up the results, right? Something that should have run first and like or probably parallel, and we have
yes.
So the results could be different.
Yes. So it largely depends upon our requirement. If you want your transactions files to get processed after your customer's file is done, suppose like you have to process the customer file and then you have to load it into a customer's table, then for reading transactions file you just have to join it with the customer's table, then you have to load the data into the table and then you have to read from it. So in those kind of requirements you have to be doing like that. So in component parallelism it scales to the number of branches of a graph. The more branches a graph has, the greater the component parallelism. If a graph has only one branch, then the component parallelism cannot occur.
Right.
Yeah. A device. Let us see how that goes for you. Okay. Yeah. The next one we have is pipeline parallelism. So pipeline parallelism occurs when several connected program components on the same branch of a graph execute simultaneously. Okay, so this is where every component in a single line executes simultaneously. So let's see that with an example. We have a single branch with customer's file, a reformat component, a filter by expression component, and then we have two output files. So when multiple components run on same data in a pipeline, pipeline parallelism will happen. So suppose we have 100 records from customer's file, and when the reformat is processing the last record, this filter by expression would have processed the already records which are coming from the reformat component before. So what it means, like, it need not wait for the reformat component to give all the records, because every record is independent of each other, right?
Like if
Filter
we
by expression
function
need not wait for
or something, then we could not have used parallelism, right?
Sorry, I couldn't hear you.
If the filter by expression, instead of filter by expression, it was something related to maximum of the records or anything like that, then it would not have worked, right?
Exactly. There are some components or some behaviors which blocks pipeline parallelism. For example, sort component. We need all the records so that the sort can particularly work correctly.
Right.
So in that case, the pipeline parallelism will not happen. So we just have to be judicious in the way of choosing our components, whether we really need a sort or not.
Right.
Because thereby we are limiting the advantage of pipeline parallelism. If we don't need a sort component, we don't need to really sort it. Having a single sort in an entire branch, it disrupts the pipeline parallelism till that branch ends.
Got it.
And if a source component must read all its records before writing any records, a sort component, for example, pipeline parallelism doesn't occur. So